Hi, I'm Lavanya. This is my project, an AI system that automatically summarizes long legal bills. Um, Legal and legislative documents are often hundreds or thousands of words long, which makes them really time consuming to read and understand. So, my project solves this by fine tuning a deep learning model that reads a full bill and generates a strong, accurate summary. Um, turning that turns a long legal document into few readable sentences, so that makes easy for everyone to understand. So here I took the bill sum data, which contains real US legislative bills paired with human written summaries. After downloading it with Kaggle Hub, I loaded into Pandas data frame with 3 columns: title, full bill text, and its reference summary. Here it is, and here you can see a sample text, uh, a sample title, a snippet of bill text, and the human written summary. So now I'm training the model to imitate. So then comes the cleaning part. So before training, I clean the data, removing any missing values that are present, calculating word counts for both the bill text and the summaries. This chart clearly shows the distribution of bill lengths, and this one shows summary lengths. I also calculated compress ratio, how much shorter the summary is compared to the original bill, and used to filter out a small number of unusual records where summary was actually longer than the source file. Finally, I split the clean data into training, validation, and the test sets. And then before doing the model development, I did the EDA, exploratory data analysis, which I used all of them to visualize the data. So here is the distribution of bill text word counts, and this is the summary word counts visualization, and here is the average length of bill text and summaries visualization. This is a summary of compression ratio. So, and then after this, and then this is the train validation and test data split, which we have took. This is the numbers. And then before dumping into deep learning, I built a simple baseline, a lead end summary that just takes first 250 words of the bill, which gives something to compare my real model against. And I score this baseline using ROPE, a standard metrics for summarization quality that measures overlap between the generated summary and the human reference summary. Here is that. This is the baseline summarization. And then comes the LED model, long former encoder decoder model. Here for the actual model I used LED, long former encoder decoder. Unlike standard transformer models, LED can handle much longer input documents, which makes it well suited for legal text. And then I fine-tuned the pre-trained model on the clean bill sum training set using Hugging Face. Because of collapse compute limiteds, I trained on the sample subset of the data with 1024 token input limit for each approach. And then the training, here's the model training. You can see the loss decreasing it to generate better summaries. And then to evaluate the results, here's the tokenized training. This is the output. Evaluating the results, once training finished, I generated a summary for text bills and compared it side by side with a human reference summary. Here it is. You can see the model captures the key points on its own words. When I evaluated fine-tuned LED model against the lead n baseline across the full test sample using row 1, 2, and some scores, as this chart shows the fine-tuned LED model outperformed the baseline on every single metric. For example, row 1 improved for about 0.43 to 0.48, and row 2 improved from about 0.17 to 0.21. This confirms the model actually learn meaningful summarization patterns rather than just copying the start of the text like the baseline does. Here are the numbers. Here the row scores, the visualized based on the numbers. And we can see that LED predictions and row comparison saves they are predicted and it's performing well. Here comes the analysis. This is the average summary length comparison of a reference summary, baseline summary type, and LED summary. So to summarize, I built and fine-tune an LED model on the BILSUM dataset. Evaluated it against the baseline using row metrics and deployed it in an interactive demo. The model consistently outperformed the baseline, showing it learned real summarization skills, not just simply copying something. There's a room to grow, so training on the full dataset using longer inputs and more approaches would likely improve much more better results further. That's it. Thank you.